You can start the session, sir.
Should I do that? No.
So we are live, you can start.
Okay. It's better. So
So it's not real time. Any question?
not yet.
Take a time.
Which is the YouTube chat active?
Yes, sir, it's active.
Okay.
How many have joined? Can you see?
At present, it's showing 6, madam. Concurrent viewers.
3 दिखा रहा है. And that includes the 2.
Of course.
Then it includes 3.
Eight. No, I'm just saying. So this is so
5 watching. That will be the questions. No, no. I am in absolutely Prof. You put a heart over here.
No, no, no. That is reaction time. Solution to
So let's do like that. Wait.
okay, which type of salt you use in CSP? It's concentrated soda. Okay, so Neelu, thank you for your question. So in concentrating solar power plants, so we usually use any type of molten salts. Okay, so salts which are having high latent heat of vaporization, we usually use those type of salts, and it varies from different plants to plant. But anyway, we will be having a more detailed live session for these lectures later. So today we are mostly focusing on the first four lectures. That is lecture 1, lecture 2, lecture 3, and lecture 4. So it will be really good if you can restrict the questions to these four lectures because,
Week one.
yeah, sorry, week 1, week 2, week 3, and week 4. So we are today focusing on these 4 weeks. Again, we will be again having the next live session soon. So there we will be focusing on week 5, week 6, week 7, and week 8. Okay, so Pranav, I have just saw your question from week 4. That is your query is regarding MSQ 13. That is, which are greenhouse gases and which are substances with ozone depleting properties, ozone depleting potential, I suppose that's what you are trying to refer to, and which have both characteristics. So most of these, see the green conventional greenhouse gases that we have, that is CO2, moisture, N2O, these are not at all ozone depleting substances, including water vapor as well. But the other ones that are there, the ozone depleting substances which we have studied in week 3. Okay, so in that, though the ozone depleting substances, most of them have both the properties that they are able to deplete the ozone as well as they are also greenhouse gases. Okay, so you need to keep in mind that the ones which are ozone depleting substances. So if you look into that lecture, we have a
all halogen.
yes, all the halogenated compounds. So if you look into that lecture over there, I'll just tell you the specific portion which you need to see. Um, So, in one of the slides, if you recall, in lecture 5 of week 3, specifically slide 11, so over there we have the halogen source gases as well as the reactive halogen gases. Okay, so all these halogen source gases, okay, so they are all greenhouse gases as well. So they are the ones which are responsible. So these source gases, as you can see, so they are ozone depleting substances that is mentioned. So they are both ozone depleting substances as well as they are also responsible for the greenhouse gas effect. And these halogen source gases in the presence of the solar UV radiation and other chemical reaction, they get converted into the reactive halogen gases, which are directly involved in the degradation of the ozone layer. Okay. So we have somebody from GLA University, Mathura. And also Ayushi, good evening. So good afternoon and good evening to all of you. Please feel free to ask questions related to week 1 to week 4. Elaborate carbon sequestration, carbon sink. Are they both same? Okay. So to give you a response to your question, a simple answer is no. Okay, so carbon sequestration and carbon sink are two different things. See, carbon sink is any natural process that is able to trap carbon dioxide from the atmosphere and therefore it is removing. So, for example, our forests or vegetation cover, they are responsible for removing the CO2 from the atmosphere. Okay, so that is why we call them as carbon sink. Our oceans, the oceans also absorb a certain amount of CO2. So, these natural processes, they are all responsible for removing the CO2 from the atmosphere. So we call them as carbon sink. Now, any process that is emitting carbon dioxide like fossil-fired power plants or automobiles and all, they are referred to as carbon source. And when we talk about carbon sequestration, so carbon sequestration is a process by which we are designing processes through which we can remove carbon dioxide from the atmosphere. For example, in week 4, you must have seen we discussed about carbon capture, utilization, and storage. So those are all carbon, they fall under the category of carbon sequestration. Okay, then there is also geoengineering, some of the strategies which we saw is that geological storage of CO2. So those are sequestration. Then mineral carbonation of CO2. So those are sequestration. So carbon sequestration are not natural processes, rather they are artificial processes which are designed by us to remove the CO2 from the atmosphere. Okay, so this is the basic difference between carbon sink and carbon sequestration. What is the peak? Okay, so the main thing was like when the Kyoto Protocol came into existence. Okay, so if you may recall, the Kyoto Protocol, the main first deadline was around 2015. So, but as you know, for obvious reasons, the Kyoto Protocol was not a success. So, to make certain amendments, the Doha Agreement came into picture, and then the Doha Agreement extended the deadline of the Kyoto Protocol to 2020. Okay, so but by then the Paris Agreement, of course, has come into existence in 2015, or rather, I would say in 2016. So now the Paris Agreement has superseded all the previous, all the previous climate change regulations, especially the Kyoto Protocol and so on. Okay, so the main purpose of the Doha Agreement of 2012 was just to extend the deadline of the Kyoto Protocol. She has not.
She didn't post anything. We can ask, has she joined?
So, okay, Tanvi, we have a question from you. Can you describe land use aerosols? Okay, so when we talk about land use aerosols, see, it depends on what type of land usage you are referring to. Say, for example, agricultural lands. Agricultural lands can give rise to aerosols in the form of pollen. Okay, so pollen, as we have seen, is a very important component of aerosol. Then, when we talk about, let's say, the what to say, the transportation sector. Over there, we end up with the PM 2.5 and all those sorts of aerosols. Okay. And then finally, when we have the, let's say, the construction and debris. So all these can, depending on the type of environment or the land usage which we are referring to, that dictates the type of aerosol that we are going to get. Then from forests, we are mostly going to get different types of bioaerosols. Okay, say for example, the forest fires and all these, they can give rise to bioaerosols. So it all depends on the type of land usage which we are looking at. If it is agricultural, it can give to pollens. If it is forest coverage, it can give rise to different types of bioaerosols. So bioaerosols, they can have microorganisms, they can have again pollens, or they can have other components of the plants. Then, as I said to you, from construction and debris or from other industrial operations, depending on the type of operation we are referring to, that will give us the different sorts of aerosols that is associated with that particular operation. Okay. So, ma'am, will you please show us calculation how we calculate growth exponential rate? Just give us a minute. We will just answer this question. We are looking for some means through which we can show it on screen.
Okay, let me try to explain it without any screen, I'll just try to explain it without a screen, okay? So, I think you know the exponential equation. Please answer my question. Yes. So, let us say n, if n is the number of people, n is equal to n0 e to the power kt. Okay, you have that, right? Yes or no? Nilu? Yeah. Okay. So when you are trying to calculate the population, N0 is your population at time t is equal to 0. Okay. And from other data, you will need to have either k value. You can either calculate the k value from a series, data series, or you should have to assume something, and so on. And then t is the time period that you're trying to predict the population for. So that's how you calculate exponential growth. Now, I think your question is growth rate. So the way to do that is, you can do many things. There are several things that you can do. If you have a series of population data, so you will have population versus year or time, okay? And you can either do curve fitting. Curve fitting is what I've explained in the lecture. The YouTube lecture has that in detail. The other option is that you take any two data points, calculate the k value, and for each and every interval, so you will get k1, k2, k3, k4, and you take the arithmetic average of that, of all those k's. Okay, and that will give you a general average k value. Is that what you need? Okay. All right.
Okay, so Pranav, I have just see your question that it is not clear to me. What are the functionalities of working group 1, 2, and 3 of the IPCC? Now, again, if you refer to slide number 13 of lecture 5 of week 4, over there you will be seeing that it is clearly defined what are the different focus of the different working group. So if you see in that slide, see the IPCC is having 195 member states, right? And then it is divided into three working groups, working group 1, working group 2, working group 3. And then we also have a task force. Now, when we look into the working group 1, it is clearly mentioned over there that it looks into the physical science basis. Now, as I already mentioned in the lecture, that IPCC itself does not conduct any research on its own. Okay, what it does is that it summarizes the scientific literature that is published related to climate change. So different model fittings, which is being done across the world by different institutes. So working group 1, based on that, they calculate all those evidence to make sure that the climate change that is happening right now is because of anthropogenic activities. Okay, so it is just about it looking into the how climate change is happening. So that is the main focus of working group 1. Then when we look into working group 2, the working group 2 is focused on climate change impacts, adaptation and vulnerabilities. So apart from like, see, first and foremost, working group 2 will look into because of the increasing, because of climate change, what are the significant impacts that are going to happen. So we saw a series of impacts in this, in the lecture in week 4, right? Then what are the different ways by how which we can adapt to those changes that are going to take place, and then who are the most vulnerable population or the population which needs immediate protection from climate change. So that is the focus of working group 2. And then working group 3 is interested in looking into different strategies through which we can reduce CO2 emission, and therefore we are able to mitigate climate change. Okay, so these are the three distinct role of the three different working groups. So working group 1 is looking into the science behind climate change. Working group 2 is about what are the impacts of climate change, what are how we should be adapting ourselves to climate change, what are the which are the vulnerable populations, and so on. And then working group 3 is all about mitigation of climate change. Okay, and then the task force looks into the greenhouse gas inventories, that is how much greenhouse gas is being emitted by different nations and from different sectors. Let's say the electricity generation, the transportation, agricultural sector, and so on. So these are the different aspects of the different portions, different groups of the IPCC. I hope it is clear to you now. So, do you have any further questions? Please feel free to post it in the chat box.
Let Shiva. Okay. All right, we'll wait for 2 minutes and then we'll end it.
So,
Let's see if we can interfere. Yeah, so
okay, so we have one more question. What is basically crop brightening? So crop brightening is mainly focused on changing the color of crops. Like make not don't imagine that it will be something white in color, but it is about making them lighter shades of green so that they are able to reflect more of the sunlight. Okay, so that is the thing about crop brightening. But anyway, as I already mentioned in that lecture, that most of these geoengineering strategies, okay, although they sound very fancy, but many of them are very unlikely to be realistic in the near future because we don't know the consequences that are going to follow from, let's say, this crop brightening or the other strategies that were discussed in this lecture. So crop brightening is mostly about changing the shade of this crop so that they're able to reflect more sunlight rather than absorbing sunlight. So they're changing from a more darker shade to a lighter color. And of course, this has to be done through genetic engineering and stuff.
what style is
Mm. Mm. Sure.
try with text first. ठीक.
Is advection also responsible for air pollution? Okay,
Yes.
Nilu Gupta, she is asking, is advection also responsible for air pollution?
Advection is a transport process. It's a fluid transport process, right? So whether it's air or water or any fluid material, when it is moving from one place to another, it's advection. Advection is something that we account for, whether it's air pollution, water pollution, any type of fluid pollution, we need to account for advection. So to answer your question, is advection responsible for air pollution? The answer would be yes. Yeah. Because air is moving from one point to the other. That is advection. And, if there are pollutants, then they will be transferred from one point to the other. Are there any other questions? Can we send our question on any email if we have any query after completion of the course? Yeah. Yes, you're welcome to send us any query even after you complete the course. Yeah. Please explain what causes indoor air pollution. Indoor air pollution has many sources. Yeah. So many of us have realized that there are so many materials that we use inside the house that contribute to air pollution, to indoor air pollution. So we have synthetic fabrics, we have synthetic compounds like pesticides and so many other compounds that we use that are all agents of indoor air pollution. That is one group. The other group of indoor air pollutants is people who use chula or biomass burning within the house. So they get particulate matter, they get CO2, they get carbon monoxide. All this builds up in the house. Then there is a third category of indoor air pollution, and that is radon gas. So radon in some areas, in certain locations, radon can seep through the subsurface into the foundation of the house. And you have a radioactive compound that is coming in volatile state. Nilu, where meaning are you talking about radon?
Where she can contact us.
Oh, I think our email IDs are already there in the website, and you can feel free to write. Yeah, just feel free to write to our official email address. Any more questions? Please ask. शिव प्रसाद जी
Yes, ma'am.
क्या करेंगे रखेंगे? Shall we continue?
You can end the session since there are no questions. You can end up the session and
Okay.
no problem.
ठीक है तो फिर we'll stop here, right?
Tell that we are ending session and
Yeah.
next live session we will meet on next live session. Just tell that.
All right. So if there are no further questions, then we'll take your leave today, and you can join next time for the next live session, and we'll be happy to answer your questions at that time.
So, okay, thank you, students, and looking forward to interacting with you again in the next live session. Thank you.